Hi, in this video I'm going to talk about the applications of neural networks. And as we have discussed earlier, that there are lots of popular techniques out there, such as the support vector machine or logistic regression, for example, or all kinds of linear classifiers that are much more popular than artificial neural networks. But on the other hand, I think that there are two main topics that are very, very interesting, and these kinds of problems can be solved very, very efficiently with the help of neural networks. And one is optical character recognition, and the second is how to detect patterns on stock market. So for example, in optical character recognition, we have an image and want to find out what character it is. So we have to construct the input layer and the output layer accordingly. For example, suppose that we have an 8 by 8 pixel image, so we have 64 pixels, and in this situation we have 64 input neuron. For example, if it's a black and white image, we can assign to each input, so all the 64 node in our input layer can be +1 if there is a pixel, or 0 if there is no pixel at all. So this is the input layer. And the output layer, we have 26 output neurons, because in the English alphabet there are 26 characters. So we would like to classify our images. We could have lots of images, and we would like to classify into 26 outputs, because there are 26 characters in the alphabet. And it's a very, very common technique, although there is no 8 by 8 pixel image. Of course, a lot more pixels there are. But this is the main approach, that we have as many input neurons as the number of pixels in an image. We have, of course, we have a hidden layer. And in the output layer, we have as many neurons, as many clusters or classes we want to use here in this situation, because we want to detect and want to classify 26 distinct characters. That's why we have 26 output neurons. And it's a very, very efficient algorithm, this neural network technique, to recognize these optical characters. And the second one is my personal favorite, the stock market forecast. We have a time and a time scale, and we monitor the price of the stock. And it's something like this. To be more technical, it is a log normal random walk. We have very, very complex mathematical techniques to grasp the fundamental processes behind stock markets with stochastic differential equations and so on. But the mathematicians at investment banks are still not able to make good predictions, and that's why these neural networks play a very, very important role in their work. And we construct the training data, for example, from 3 data points, but of course we could have 10 data points plus the next one. And we want to make prediction if we have, for example, 3 points. As I said earlier, it can be 10 points or 20 points. What will be the stock price tomorrow? So we have for example, we just monitor 3 distinct time, and we calculate the stock price at that time. So for example, the first is the P11. I'm not going to use it numbers. It could be 3.11, it could be 9.11, whatever, it doesn't matter. The fact that we keep constructing a training set according to this, that we monitor each of these parameters, and then the prediction is going to be the next one. And we know it because we have this graph. We just have to calculate the prices accordingly. Then we shift our calculations to the right. Then P21, P22, P23, and the new prediction will be the next one. Why is it good? Because we keep constructing a training set with which we are able to predict, according to the 3 previous stock prices, we are able to predict the next one. So we keep constructing like this, the next one, and the next one, and we keep shifting or interval to the right and right. And why is it good? Because we have trained our neural network according to this data set. We have the input layers, we have a hidden layer, we have an output layer, we have a data set. All we have to do is make as many iterations so as to reduce the error term to a minimum. And then in this situation, the edge weights are optimal in our neural networks. So if we present three data, the price 1, the price 2, and the price 3, three different prices at given distinct days, then our neural network or trained neural network will be able to predict approximately, not 100% sure, but approximately the stock price tomorrow. So we train our neural network on this data, and if we provide X, Y, Z, three previous value, it may predict the stock price tomorrow. So this is a very, very common techniques in investment banks. Not this situation, not just three price, not in this manner, but the technique is the same. So that's all about the applications. Thanks for watching.